everybody, and welcome to the Supplemental Instruction series of videos for Chemistry 121. My name is Smokey, and in today's episode we're going to be practicing a bit with balancing chemical reactions.
Because they make things go.
Yes, they do.
By the way, my name is Kevin Martin.
And we'll be presenting this episode for you guys today.
So, balancing. If I recall correctly, there's something called the second law of thermodynamics.
That's right, there absolutely is.
Okay, and if I remember correctly, that says that matter can't be created or destroyed, right?
Exactly. So when we have a reaction like this, basically what that means is that the stuff we start with as the reactants, we're going to end up with the same stuff as the products. I mean, obviously it's a reaction, you're changing chemicals and all that, but the number of things that you start with, like for example the number of oxygen, is going to be the same in both the reactants and the products.
Makes sense.
So you can tell, Kevin, that this is unbalanced. And
right.
If you look at the oxygen, that's because we have 4 here and only 1 over there.
Yeah, that's a problem.
It is a problem. So, do you have any ideas how we might fix that problem?
Oh, okay. So you have to make the same number of oxygens on this side and on this side.
Mm-hmm.
Now, if I remember correctly, can we do anything with these numbers here?
We don't. Those are the subscripts.
Oh, okay.
Remember, those are, so for example, for Fe3O4, we can't change those subscripts because otherwise we're changing the chemical.
Ah, okay, that makes sense.
Right, but we can change the number of those chemicals. So for example, if we put a coefficient like a 2 right here, that's saying we have 2 Fe3O4s.
Oh, okay.
That make sense?
So we can basically just, have more than one of that.
Exactly.
Okay.
Yep.
Now, balancing.
Yes.
What exactly would I start with if I wanted to balance this thing?
Well, see, the problem with chemical reactions, balancing chemical reactions, is that, there's no real cut and dry, easy way, really method to do it. So the best way to learn it is to just do a whole bunch of problems and kind of get used to it. But there are some little tricks that you can do to help make it a little bit easier.
Okay, good. I don't like doing work.
Exactly. So, for example, in this problem, we see that we have a metal present. It's the iron. So when you balance the chemical reaction that has a metal in it, usually it's better to balance the metal part first because you might get lucky, and once you balance the metal part, the non-metal part will automatically be balanced by itself.
Oh, okay, so... Alright, that makes sense. So, alright, so if there's 3 irons here, 1 iron here, so we can't just stick a subscript of 3 in it. That wouldn't make any sense.
Right, but we can't put the coefficient there.
So if I just do this, that work?
That does work, because
Okay.
that puts 3 here and 3 here.
Alright, cool.
Okay?
Alright, now, what should I go to next?
Well, I would say that after you balance your metals, oxygen is probably the next thing you're going to want to look at.
Okay. So, there's 4 oxygens here, then 1 oxygen here. Can't put any subscripts in, so I'll just have to put in a coefficient.
Right.
So if I put a 4 here, that'll give us oxygens.
Yep, 4 oxygens.
Alright.
But remember what you did here is that since you put the 4 there, you're also changing the number of hydrogens.
Oh, so basically you're taking, 4 times, the 2 H's, so that's a total of 8.
Right, exactly.
Okay.
So now that we know we have, basically the iron and the oxygen is balanced at this point, which leaves only one thing left, and that's the hydrogen.
Okay. So, if I want 8 on this side, well, I just have to put a 4 there as well.
There we go, and that's it.
Alright, so checking. So 3 irons, that's good.
Yep.
4 oxygens, 4 times 1 is 4 oxygens, 4 times 2, 8 hydrogens, 4 times 2, 8 hydrogens.
It's balanced, there we go.
Yes!
Physics would be proud of us. Alright. So.
Ooh, that one looks interesting.
Yes, this is actually kind of a special form of an acid-base reaction.
Oh, really? Interesting.
Yeah.
Well, okay, I guess we'll start tackling it. Now, I guess we start with the metals, right?
Yep. So we have aluminum as the metal, obviously.
Oh, there's also sodium. I'll just start with aluminum.
That brings up a good point. So we're between sodium and aluminum.
Mm-hmm.
So which one would you want to pick?
Well, I don't know. Personally, I would just start with the first metal that they list.
That works. That, and also you can tell, since there's 2 aluminums here and only 1 sodium here, it's probably in our best interest to balance the aluminums first.
Okay, that makes sense. So there's 2 aluminums here, and then there's only 1 aluminum here.
Mm-hmm.
So I guess that means I'd have to put a 2 here in order to, balance the number of aluminums.
Yep.
Okay, so those are all well and good.
Mm-hmm.
So now sodium. There's 1 on this side, 2 on this side. Well,
yep.
You just have to put a 2 there, I guess.
Yep.
Okay. Well.
Looks like you kind of had a bit of a problem here.
Yes, because I have, this stuff here and then the OH there. So
right.
How would I tackle that?
Okay, so when you see big groups of things like that, like your polyatomic ions, what you want to do is look at them as a whole entity. Mm-hmm. So basically you want to look at the SO4, there's 3 of them, and then you have only 1 SO4.
Oh, I get it, because you can look at it that way, because between the reactants and the products, the sulfate's still the sulfate, it's not going to change. So
SO4 is SO4.
So I don't have to break it apart into the sulfurs and the oxygens, right?
Exactly.
Well, geez, that's a lot easier.
It does. Yeah, it is.
Apart. Okay.
Definitely.
Well, okay, I'll just, go with that. So there's 3 sulfates. Alright. So here there's only 1 sulfate.
Mm-hmm.
So I guess I put a 3 there.
Yep.
But wait a minute.
That changed your sodiums.
That's right. So now there's 6 sodiums.
Mm-hmm.
There's only 2 here. So I guess I would have to change this to a 6 then.
Yep. And that gives us 6 sodiums, but remember, you change your hydroxides, the OH.
Well, okay, so OH, so 6 hydroxides here, 2 times 3, 6.
It's already balanced.
Well, geez, that was quite nifty.
See what happens if you really, sometimes you get lucky like that. If you start with the metals, and kind of work your way through it, sometimes some of the other ones will just magically balance themselves
Well, hopefully I get that lucky that often.
Exactly. It's pretty cool.
That would be nice, yeah.
Alright, well Kevin, we've covered a couple of them. We have the metals ones, but there is another type of chemical reaction, the combustion reaction, that is kind of different in a way.
Oh, really?
Yes, so I'm going to go ahead and put a really basic one up here.
Okay.